Focusing. We now introduce Dr. Carsten Giebeler, Managing Director at Spectrolytic Ltd. He will be sharing knowledge on advancement in inline oil condition monitoring.
Okay, am I ready to go?
Yes.
Yeah. Oh, yeah, well, hello, good morning, good day, wherever you are in this world. And as a moderator said, I'm going to give you an update on the progress that we've made with our inline oil condition monitoring systems. Now, a little bit about me. So I'm the managing director here of Spectrolytic Ltd, but obviously all the data is really down to the team. I used to do interesting things, but now really only try and focus on running the company and making progress with this. So we are a little bit sort of the new kids on the block. From last year, we introduced our inline system, and to explain what we are doing is we've developed inline systems, and our claim to fame is that our sensors really measure and show the oil degradation parameters in exactly the same units and with exactly the same accuracy as you get from conventional oil laboratories. So for the end user, this really lowers the barrier of entry because the end user can use his existing knowledge that he has from analyzing conventional oil reports, and he can just look at the sensor data and it's the same unit and it matches one-to-one. So he can immediately react in case any weird values come out of it because he knows how to understand this. And compared to last year we focused on the first generation of the inline sensor, and also last year we have now updated the inline sensor and also introduced a portable system that works in exactly the same way with exactly the same accuracy. And we will show or talk about this later on. So this slide here really summarizes what Spectrolytic is all about. We are trying to streamline and optimize the, let's say, oil analysis process. So the conventional way of doing is you have a sample point that could be an engine, a steelwork, whatever it might be. Then you have a person who has to take a sample, which is a problem in itself. Then it has to be shipped to the lab analyzed there. And then depending where you are, in Europe, it might take a few days. If you're further afield, it can take weeks until you get the results back. And in this time, you're basically flying blind. And in order to optimize this and speed this up, we have developed our portable system where you still need a person to take a sample, but at least you get the results within 5 minutes. Or the inline system where you get basically an oil analysis 24/7 whenever you want it. So the way our sensors work, it's based on mid-infrared spectroscopy. So we have developed a spectrometer platform that has no moving parts, is completely robust, and mid-infrared is also the tool that is used in oil laboratories, and therefore we use exactly the same analytical methods in our sensors to analyze the oils. So, like any sensor, its working principle is relatively easy. You have an emitter that shines light through a sample, and then you have a detector that detects the signal. And obviously the devil is in the detail, how to work all this out that you get reliable data. That's sort of the crux, and this is what we have developed. So our sensors, we have developed in such a way that we can extract all the relevant oil degradation parameters directly from the infrared data. So in order to turn a spectrometer, which our platform is, it's a spectrometer platform without any moving parts in the mid-infrared, into an analyzer, you have to give the spectrometer a calibration file. If not, it just measures. So, and with this calibration file, it then turns into a dedicated oil analyzer. And we have developed a process that allows us to generate these calibration files from historic oil reference analysis data that the customers might have. So this is a very efficient process. The only thing that needs to be sent is data and reference analysis via email. Then we can configure the sensors in the correct way for a given application. So there's no need to ship any oil samples anymore in order to set our sensors up. Compared to other sensors, we are obviously not the first one who does inline oil analysis. There are plenty of other solutions out there. But as I've mentioned before, the key difference is really that with our sensors, we measure each of these parameters individually, and we measure them in exactly the same units as mentioned before. So here you see a nice typical plot of the oxidation over time, and the red dots are the reference analysis that are still periodically taken by customers. And you can see, you can just compare the data one-to-one because they are in exactly the same units. In our dashboard functionality, so the customer can introduce warning levels and action levels, and this can all be automated so that alerts are sent to the customers, and this is obviously fairly standard. So competing technologies are usually using slightly different approaches. They use a dielectric constant or impedance. So these are more summation parameters. So often the customer only gets one parameter at the end, a dielectric constant or a bulk resistance. And this is not something a field application engineer is typically comfortable with or knows how to interpret it. So it then requires it requires an effort and more assistance to analyze it. And in general, it's very, very difficult to differentiate multiple degradation mechanisms that might have opposing effects on the dielectric constant from getting this one data. So this is really where we differentiate. We look at each of these parameters individually and present them in an easy to understand format. So our product line consists of the inline and the portable. Here's the inline. It's been developed to be really plug and play. The installation can be done remotely. It typically takes half an hour to an hour. You can have these sensors equipped either with a pump or with a valve version, depending how you want to present the oil sample to the sensor. The data gets sent initially, at least, via LTE to our cloud. This is just to avoid any interference with the company's IT systems, so that we don't need any access to it. It's completely decoupled. The data gets sent to our cloud, and we make the data available to the customer in whatever format they want it. We also have the options of Modbus and other interfaces, so that later on the data can be directly integrated into a customer's on-site control system if this is what's required. We also have the option to combine our sensor, which focuses more on parameters like oxidation, nitration, the things that you can measure with infrared, with, for example, particle counters or viscosity sensors, so that you get a much more complete solution for your oil condition monitoring. But these particle counters, additional sensors, they are not developed by us, but we just buy them in, integrate them, but so that the data that gets transferred is just one package that can then be easily integrated. Here is the portable sensor. So the portable sensor still requires a person to collect the sample. The sample is then put into a flow cell that you can see here on the left-hand side, which is then placed into the system here. And the data are then, the results are then displayed on a tablet or on a display on a laptop that runs our software. And the portable analyzer can be configured to measure really any base oils from group 1 to 3 phosphate ester, polyol ester oils. For the group 5 oils, we need a different configuration. So depending on the application, you might need 1 or 2 systems, depending how many oils you want to measure. In principle, you can measure with 1 system multiple oils. So these systems will then be set up as described before, and you will have a drop-down menu where you select the correct calibration file, and then you load the sample and the results are displayed. So compared to last year, where we sort of started off with our first generation, which you see here, on gas engine and some implication on moving vehicles, we have now progressed in other areas. We have installations now in steel and aluminium working plants, some compressor installations, and the portable fluid inspectors has been delivered to nuclear plants in Asia. So here you see a nice image of the second generation of our systems. It's been installed in a steel plant with the aim of really monitoring the water ingestion and also some additional additive emulsifier concentration in the rolling oil. So here you see a typical result. So our sensor is very, very sensitive to water, and we typically detect the water ingress a day, 1 to 2 days before it actually picked up at the actual steel plant. There are 2 reasons for them. One is obviously the sampling regimes that they have, but the other reason is also that there analysis seems to be not too sensitive, and it really kicks up if you have above 1,000 ppm. So with our system, as I say, it reacts immediately, and you can therefore then, start taking reactive actions in the steel plant. Here, the blue line shows once they've detected a water ingress, then they switch on a centrifuge, and this then takes out the water again, and the system comes back to normal. So here on the next slide, you see a comparison between our sensor data and the laboratory results. So here you can see the 0.1. This is what they have measured, and this is what we are measuring as well. And here you have slightly higher concentration, 0.3. As I say, this matches all very nicely. One nice way of looking at the data in a different way is you can potentially even use this data to think about failure mode analysis. You can see from this data here, you have one leakage, one type, which looks like a continuous leak, where you can see here there's a water ingress over a period of time, which is here and which is here. Whereas here's a middle one, this is has a different shape. So you can see here it sort of jumps up immediately, which seems to be a much more, faster failure mode. And obviously, working backwards, you can then implement this into software to really try and pinpoint from these data to figure out where the actually leak occurred. Another installation is in an aluminium plant, which you can see here. So for the aluminium plant, it's very important to ensure that the product that they make is nice and shiny and has no blotches. And for this, they use a number of additives to achieve this. But these additives get used up during the production, and it's important to monitor this. And this is quite a lot of effort, as it requires a lot of sample taking and analysis. And here you see the result of the sensor. So there are different types of additives. Some of them are used up very quickly. Some of them are not used up at all over time. So, and you can see here, the interesting part is really the lower one. This is the additive that is used up very, very quickly. And here the customer basically, they put in sacks of additive, and you can see whenever they put in an additive sack, you can see how the signal then increases. You can even see that there is a little time lag between when they actually put in the sack and the sensor reacts, and this has been confirmed because there's some sort of reaction going on that releases this additive. So all these granularity can be really detected with our sensor. It's also interesting to note that these additives here have completely different concentration ranges. So it's basically a factor of 100 different. And however, we can still configure one sensor to be able to measure all these different additives in the completely different concentration ranges with just one simple solution. The next one was a little adventure into sort of polyester oils, which we haven't done before. Obviously, they work slightly different, and there the degradation process is driven by a hydrolysis. And this is a compressor oil that has been installed on a large compressor. And we went with a customer through the process of, he sent us the data, historic reference analysis. We set up the sensor and here installed it. And here you see the results of the comparison between the measured data and the reference analysis. So the parameters that we detect is the viscosity, water, ester breakdown, and the total acid number. And you can see for water, ester breakdown, and the acid number, we have an R square of larger than 0.95, which is pretty accurate, considering that 1 is sort of the maximum you can achieve. For the viscosity, we are a little bit lower, which is 0.85. But the viscosity, to be honest, this is an indirect measurement where we have developed some algorithms to detect it from infrared measurements. So for applications where viscosity is a nice to have and not critical, it works with our sensor. But if viscosity is mission critical, you shouldn't rely on it. We also ventured a little bit in marine application, which seems to be getting now more and more traction. So this one here is an installation to measure the scrape oil, the TBN in scrape oil on a Castrol Cyclex oil. So the range that where we set up the calibration file for was from 5 to 40. And the sensor has then been installed, and here in the middle you see the results from the measurement, and you can see that it measures the TBN very, very accurately with an average error of around 1.3 milligram KOH, which, considering you only want to know whether you have any base left in your oil, that is more than sufficient, and the customer is quite happy with this. We are now also venturing a little bit into these EAL oil, which is environmental acceptable lubricants for marine application, which work very, very similar to these polyester oils, and we are hoping to get installation in this area fairly soon, and hopefully we can update you next year. So, and last but not least, here's an example of the portable system. So the portable system, it needs to be configured for the oils that the end customer wants to use, and this is a nuclear plant in China. You can see as I have quite a number of different oils for quite a lot of number of different applications. And so we went with them through the same process as before. They provided us historic reference analysis data. We configured the sensor, and they are now at the plant in use, and it's working very well. And because this Fryquell EHC, this is a Group 5 oil, and because that works completely differently from the other oils, so this is why this customer required 2 systems to cover all these different applications. And this really finishes the presentation from my side. I hope you enjoyed it, and if you have any questions, I'm happy to answer it. Thanks a lot.